Which is the conjugate acid of the following? And so what we have here is we have a structure that has an alcohol and it has an amine. And so if we're looking for a conjugate acid, that means we want this molecule to act as a base. And we're going to react it with some sort of acid. So I am just going to use hydrochloric acid as a stand-in for generic acid. And you don't necessarily need to do this, but it gives us a way to visualize what's taking place in this reaction. And so if this is your acid, that means that this molecule here has to act as a base. And so a base is going to be something that can accept a proton. So, or donate a lone pair of electrons is another way to think of that. And we've got two atoms that have lone pairs of electrons. So we have two lone pairs of electrons on the oxygen, and we have one lone pair of electrons on the nitrogen. So we need to decide where are we going to add that proton. So it's a little bit counterintuitive here, but you want to think about which one is actually going to form the weakest acid. And that's where it's going to be protonated at. So where would it form the weakest acid? Okay, so we've got a nitrogen and we've got an oxygen. And so the trend when we're looking at atom, if you're comparing across a row of the periodic table, like this second row of the periodic table, we know that acidity increases as we are going across. So what this tells us, and this goes with increasing electron negativity. So this tells us that if we added the hydrogen to the oxygen, then it would be a stronger acid. So that means that we are more likely to add the hydrogen to the nitrogen to give us the weaker acid. So this is what's going to take place in this reaction. Your nitrogen will pick up the extra proton, and if you're reacting with HCl, you would break the hydrogen-chlorine bond. And so this would form the molecule where you have a protonated amine, so NH3+, and that OH. And if it was hydrochloric acid, you'd also form the conjugate base, which would be chloride. But we're only asked about the conjugate acid, so we want to identify that we haven't added the proton to the nitrogen. So we were really comparing between A and B. And so we noticed that these are conjugate acids because we've picked up a proton. C and D are actually the conjugate bases. So we don't want to look at those, we just want to look at the conjugate acids.